Welcome back to another Daishinfinity video. In this video, we're going to talk about the so-called Russell paradox, which states that there exists a set M such that for all x in the universe, mathematical universe, that the set is in M. So we are trying to say that there exists a set such that for every set, the set is in the set M. So the set M is like the containing all of the sets. And this is something that is actually non-existent. So I'm trying to prove that there exists none of those sets M such that for all x is not in M. Okay. And let's try to prove this by using contraposition. So let's say let there be a set M such that there exists a set M such that for all x is an element of M, or x is a subset of M. Now, if we have this, we can have a small trick here. Since we are trying to say that there is a set M such that for every subset or any set in the mathematical universe x is in M. So let's just try to define something that is not in M, or that is in M, but the set x doesn't contain itself. So let's define a rest class of sets. I'll just call it rest set R, and I'll define it as all x, so all sets x that are in M, but have to have this as a mathematical way, so that the set x is not containing itself. So if we define this rest set, we can actually say that we can see two opportunities or two cases. So let's look at two cases here. So the first case is that when the rest set is an element of the rest set, we can see that if the rest set is an element of the rest set, then the rest set per definition is defined as a set that is in M, such that the set is not containing itself. So since the rest set is in the rest set is in an element of M, which states that the rest set is not an element of itself. So it implies that the rest set is not an element of the rest set. Okay, the second case, so the rest set doesn't contain itself. That is what I want to say. Now let's say that the rest set doesn't contain itself, so the rest set is not an element of the rest set. Since the rest set is not the rest set, it actually is corresponding to its definition of R, since the rest set again is defined as a set, any set x. I will just take R, which is in M, so R is in M, that doesn't contain itself. So since this is just this one, it actually listens to its definition. since it listens to the definition, it also it also implies that any set X is not the is not the own set, since if X is not in X, it obviously implies that for any, or maybe there exists an element X in X such that X is not in X, so X is not X. Okay, so if this is true, then X is not X. Okay, and if X is not X, it means that X doesn't contain itself, so X is not an element of X. So we can actually say that if X is not X, it is equivalent to saying X is not an element of X. So we can go this way or this way, it doesn't matter. Okay, since X is not an element of X, X is in the rest class, since the rest class is again defined as a set X in M, such that the set X is not an element of the own set X. So it means that through this, the rest class should be an element of the rest class. Since if we put X to be R, so X to be R, then we have R element of R. So now we have proven that if R is not an element of R, it implies that R is an element of R. And at the very end, by proving two cases, we have found that if R is not an element of R, it implies that R is an element of R, and if R is not an if R is an element of R, then R is not an element of R. So since we have both implications, we can actually say it is equivalent to saying that R is not an element of R equals R is an element of R. But there is no set in a mathematical universe that says a set is not an element of the own set, which is actually equal to set as an element of its own set, contain itself and not containing itself. This is actually not possible at all. So we can actually imply that there exists no sets M such that for all X is in M. Okay, so I hope you guys enjoyed this video. Please like and subscribe. This video was a bit philosophical and logic and a bit of the metaverse thinking, but I hope you guys enjoyed, and please like and subscribe, and we will see us next in the next Daishinfinity video. See ya.